As the AI market continues to grow within the IT space, ensuring your physical infrastructure is prepared is more critical than ever. During today's webinar, we'll discuss the vital components needed to support AI advancements, such as the importance of pathways and cabinets in your infrastructure, ensuring your PDUs meet thermal requirements, effective cooling solutions for cabinets, and enhancing fiber connectivity to support large-scale AI solutions. Today's presenter is Jeff Paliga. Jeff is the Director of Business Development for Panduit's Network Infrastructure Data Center business and is responsible for setting the strategic direction for the global data center business, as well as identifying and developing technical alliances with global organizations. Jeff, I'll hand the call over to you now.
Thanks, Kelly. Appreciate that. And thanks, everybody, for joining. As Kelly said, my name is Jeff Paliga. My role as Director of Business Development as part of our data center business unit. A big part of that role is to constantly be looking downfield for next generation trends and technologies and drivers that would impact our business and our customers' business and our partners' business as we move forward. So when you hear things like artificial intelligence, that certainly fits the bill. In fact, I wouldn't say that's too far down the road. It's actually pretty much on top of us today. But ultimately, when we've done this in the past, we've looked at technologies historically, things like virtualization, cloud, edge deployments, and now AI. Regardless of any of those technologies or trends in the past, ultimately what happens for those technologies to be deployed, they have to be physically and literally deployed in some type of space, in an IT environment, data centers typically. But no matter what those trends are, we look to figure out what those mean and then ultimately how that gets deployed and delivered in a true sense. And that's really what our time today will be about. I'll cover some things on the market, some trends and drivers, some things that are grabbing the headlines, but ultimately, what are the things that we should all be looking at to prepare for this? And I know some of these previous technologies may have been overpromised, or the scale, maybe there's a little bit more of a slower hockey stick, gradual hockey stick uplift. AI certainly seems to be something that is driving a lot faster and a larger scale than probably anything we've seen in the past. So I think the proper place to start is actually defining what AI is, right? Artificial intelligence. Probably multiple definitions what that is, but I think really at the core what I liked is AI is really the process of having computers perform those tasks that normally we do, that humans usually complete, right? And it's really, in a sense, really no different than what computers have been doing and servers have been doing for years, is trying to simplify our lives, right? Make the complicated easy, take out inefficiencies, become more efficient, faster, adaptable, quicker, agile, to conduct all types of services and workloads and applications. And so even inside AI, there's various levels of computing and different types. And I'm going to get into two major types of the computing for AI. But ultimately, what that means, right? It's a bit of a cause and effect, right? So the cause is the driver for this, and the effect is increased computing capabilities, right? The volume and the scale at which AI is growing is tremendous. So that's the biggest driver. And then if you're going to drive up computing capabilities, it goes hand in hand with power consumption. No surprise there, but power seems to be always the key. Again, if you think back on previous technologies or just previous experience for most probably people on the call walking through data centers or owning or operating your own data centers, there's always a handful of limiting factors. The one I always seem to come back to is power, right? I've walked through data centers years ago, and you see full racks and cabinets deployed, full meaning number-wise, but what's inside that might be a quarter full or half full. And typically, again, there's different reasons, but typically that's because there's just not enough power available. And this is pre-AI. This goes back decades of seeing, facilities half populated just because they couldn't get the right amount of power. They planned insufficiently for power to get there. And not so much cooling then, but again, today I'll talk a bit about more cooling. That's another factor today, but ultimately that's what it turns out to, is having more compute, ultimately having more power, and being able to plan that provision for that accordingly. And so when we look at what the market is doing, as I said, we'll cover some of the topics that are here. but the growth is tremendous. It's absolutely amazing. Where you think about the amount of data center power globally is being consumed, the folks estimate about 3% of all the world's power is going into data centers. But when you look at what specifically is forecasted for AI, it's estimating about 25 or 10% by next year, by 2025. Again, and the adoption rates are very fast, very high, 40% compounded annual growth rate for the adoption of AI. And then that third bullet is sort of a use case, right? And we'll talk a little bit lightly on some of the use cases, but for most people, they know Netflix moved to a cloud model years ago to run their business, and now they start incorporating AI and they're showing serious savings, $1 billion in savings, and reducing customer attrition, just because it has this intelligence built in to make the customer, the user experience that much better. So there's a lot of times we see technologies and maybe the use cases aren't there. In this case, it certainly is. And then ultimately, right, a rising tide raises all ships or all boats. So the last bullet point, AI is expected to significantly contribute, according to PwC, 1.6 trillion globally to the economy. Now that's everything, right? That's the equipment, the hardware, the software, the services, the benefits, the business models. But ultimately, that's a big number to attach to. So really what that equates to over to the right is, again, a little bit more of that practical approach to this is it's going to require 10 times more power per rack. So if I just told you guys that, power was sort of has been a limiting factor in the past, it's going to continue and more so as we go forward. The amount of spend, right? So what's at the core of this are all these GPUs, the move from CPUs to GPUs, 4 times as many, the spend, 4 times as much spend on these GPUs over the next few years. And then very close to home, that ultimately turns into 4 times as much fiber cables per rack. So like I said in the opening, right, as much as the technologies are talked about at a high level, ultimately the way we on this call and our partners and customers deploy it is going to have a direct impact on how we approach this business going forward, physically and both literally. Oops. So let's just talk a little bit. Part of the title was, AI and Infrastructure 101. So the two major areas for AI are kind of put in these 2 buckets here: training and inferencing or inference. And really, when you think about artificial intelligence, just in the title itself, right, intelligence, it's a learning model, right? And so it's really, quite honestly, not much different than for us as human beings of how we learn and get educated and experienced, right? So really, you can't have AI if you don't have the training portion. Think of the training as building, the big brain, or going to school and taking classes to get experience. So you have to have both for AI to be really worthy, but you have to have the training piece first. So the training is taking a topic or a model and teaching it and helping it learn as best it can, as much as it can, as accurately as it can. So that is a good core fundamental foundation for additional learning, right? So if we aren't trained properly, if we're not educated properly growing up, we have a tough time with the advanced concepts and moving on, right? So today, what we're all seeing mainly in the headlines typically is the training side of it, right? The big investment, the big power consumption, the big deployments. Again, this is pretty pragmatic, right? You have to build that model before you can start putting on the inferences in other locations. So you have the training to build a model, and then the inferencing is taking that model and then actually utilizing it, making predictive decisions, adding that intelligence, looking for actionable results, the benefits that we all see going forward. So if you kind of look at the diagram there, what it's showing is off to the left is really an untrained, a typical network, right? Almost maybe looks like the connections in our brains, if you will, but like that's a pretty typical network that's doing its own thing. When you move into the training module, now you're starting to apply data sets and information to really train and hone the skills inside that architecture. So now you're building that base, that core, and now it makes more sense. It's more connected. And then you move to the inference model. Again, I don't know everybody's background on the call, but an inference model, my guess would be most people on call is something we're all going to start seeing more as we go forward. So we're seeing the big companies build the brain and the connectivity and build the training models. And ultimately, those turn into smaller business apps and workloads and applications we will start deploying in our environment, maybe not at the same scale and mass as the brain is, but the inference is where it all happens. And what I find interesting is, I forget where I heard it, but a lot of people say, the training portion costs money and the inference portion makes money, right? So again, the analogy is like if we're getting trained through school, when you're in school, maybe you can college or even high school grades, you're paying tuition, you're paying to learn, there's an investment in you. But when you get out and you're in the workforce, you're earning a salary, you're providing value. It's very, very much similar to the way that thing works, and no surprise, right? That's kind of how intelligence works. You get exposed to data, there's good and bad, there's trial and error, but you become an expert. And that's really what I think most of us are going to see on that inference model, how we go to deploy that today or get ready to deploy that in the near future. So training costs money, inference makes money. So just to speak to that, right? So again, the headlines are talking about AI adoption. Again, you can't say AI today without mentioning Nvidia. They own somewhere between 85, 95% of the market. And what this slide is showing here is basically where those opportunities are. So what you see in the bar chart is the blue bar is the investment or the revenue on training, and the light green is kind of the money. This is specific to Nvidia. The training is the light green. So today, again, like I said, that model's being built. You build the brain, you build the architecture, and then you start pushing that out to the inference model, which will probably be more closer to home for a lot of us on the call today. And so the expectation over to the right, at least the forecast is coming out of Dell World, the expectation is there's going to be a rapid shift from training to inference. And the thought is in the next 6 years, those blue bars will change over. Only 10% of the compute demand will be for training, and the inverse will be for inference. Again, so if we think things are growing fast now and consuming a lot of power and data and space, it's gonna rapidly shift, right? Again, you want to invest, you're going to spend money on training, but it's when business models start making money that the entire market starts moving forward. So again, I think we're at a point where the foundation is being built, and most companies are looking at AI. A lot have deployed it, but I think most of us are going to experience this in the near future. And just a quick example. So when you talk about inferencing, like what are some of the business models out there today, right? So we all hear about autonomous driving and driverless cars, any type of predictive analytics. Anytime you type something in ChatGPT, think about when even your emails, when you're typing a word or sentence, it's finishing your sentences for you. It's giving you recommendations on spelling. I mean, all this ties back to having a really good, solid model at a training level that we're seeing at an inference level. Financial models make great sense. Cybersecurity models certainly make sense. And then again, potentially, your near, current, soon-to-be application business models are something that's probably going to benefit and utilize some type of AI in your IT spend and architecture in the near future. So when we look at all that, so it's great news, right? There's a lot happening there when you look at it. So the trends we're seeing, again, ultimately, power cooling and fiber density for AI is beyond anything we can imagine today. And most of the new DC builds, even more recent builds, are starting provision and plan for AI. I would tell you, which means on the contrary, most of the builds that have been done in the last few years or later are probably not going to be sufficient. And that could apply for any scale, right? Whether you're doing these huge pods or you're doing a small handful of cabinet deployments, there's a lot of power, a lot of punch packed in these cabinets as they come out. So it's going to require a lot more thought and design and redesigning of things around the power consumption, if there's even enough power to support these things. When you look at how a lot of these things get rolled out today, a lot of the AI large systems are being done by rack and stack. They're being done by integrators because they're highly engineered. Again, for the enterprise customer, maybe you don't need the 16 cabinet pod, but you're going to have 1 or 2 GPU servers, in a building, small handful, but nonetheless, it does require a little bit different change in understanding how to deploy that. That next bullet point, as I mentioned, right, being in the data center for a number of years, liquid cooling, right? You think back 10 years ago or maybe longer, maybe less, nobody really wanted to bring liquid in the data center, right? It's a bad mix when you're bringing liquid with electronics, high expensive, valuable electronics. That's a bad mix, but it's something now today is happening, right? So things like direct to the chip needs to be in place. It needs to be incorporated, because as you can see, the kWs per rack, which is, again, mind-boggling to me, legitimately hitting 120 kW per rack. For those that have been in the business for a while, remember the 150 watts per square foot, 300 watts per square foot. Those days are long gone. This is 120 kW per cabinet. Then ultimately, again, fiber will, as we've all seen over the years, will remain strong. It's definitely going to be used for all rack to rack. connections. There is some copper inside, maybe some point-to-point, some small inter-cabinet cabling, but fiber will remain the dominant infrastructure of choice as AI continues to be adopted. And so all that being said, right, so kind of what I'm trying to put here is any scale of AI, whether you're putting in the big pods or you're a small enterprise, right, it definitely is going to take some rethinking, a new approach to look at it. Sort of the image there, the calm before the storm, right? As I said, the storm's going, right? The AI market is heading there. I think a lot of it is around the training portion of it, but the inference piece is where it's going to hit closer home for many people. So our current designs, they're going to need to change. They're going to need to be purposely built for AI. Again, the rate of adoption is increasingly fast, right? Not only is the build out happening, but the models are starting to roll out much quicker. And as you can see, based on the power requirements, these things are really hitting close to home as we continue to move forward. And then lastly, your existing data center, whatever challenges you might have today, whether it's power, space, connectivity, cooling, they're only going to get magnified, right? So it's going to uncover some weaknesses that are pretty quick as we move forward. So again, I think about this too, right? I touch on some of the other previous technologies and being ready for that. But I think of AI when I think about things like when Cisco put out, I think it was in the 2008 timeline, they put out the Nexus 7K. That was the biggest switch chassis we've ever seen, right? Or things like blade servers. There were a lot of great benefits around those technologies, but the very beginning, people really weren't ready. They didn't really provision properly. So all the promise of blade servers really had a little bit of a pause because, again, we couldn't stack an entire cabinet or rack full because we were out of power or there wasn't enough cooling for that. So as we got more mature and more knowledgeable, we start provisioning and building and enabling those types of configurations. So I think that times 10 is what we're going to see with AI if we don't provision accordingly starting today. And so what does that look like? So this is a busy chart, but it has a lot of really good information on it. So when you just look across the board, right? So the servers, as I've sort of alluded to, are evolving from CPU to GPU. That's at the core of where this is going, right? You look at some of the even the connectivity and links for servers. It's changing. It's really going for GPU to GPU. It wants direct connectivity. It wants low latency, high performance, really just off the charts connectivity and performance across the board that you can only get with GPU to GPU connectivity. You look at the connectivity, right? We're all very familiar with the duplex LCs. When you start getting into AI, it's MPO connectivity, it's angle polish, right? High performance, uninhibited performance to go across all those links, switch to switch, and GPU to GPU, right? And so from that, the architecture is certainly going to change, right? So it's still going to be a leaf to spine, but it's going to be at a high performance level where you can see things like where we were talking, it just seems like that long ago, we were talking 1 gig, 10 gig, 40 gig. Again, AI is really bringing forward a lot of the things we have talked about in the past, bringing it to reality. So we're not talking 10 gig here, we're not talking 100 gig. The hyperscalers are at 800 gig, AI is at 400 gig and quickly moving to 800 gig. So things are moving quick. The protocol, InfiniBand is the protocol of choice here. Again, I talked about fiber. Both fiber, multi-mode and single mode, are viable inside this environment. Depending on the configuration and size of the deployment, fiber is going to be the media of choice. Today, again, I'm kind of working right to left here. So, typically the enterprise data center is somewhere, it says 5 to 15. I see it somewhere between 8 and 10. Nonetheless, we've seen the shift for some of the big cloud providers and hyperscale providers move that to 10 to 20. AI is quickly moving that from 40 to 120 kW, right? So again, we're not talking about 150 watts per square foot. We're talking kWs per cabinet, significantly higher. And you start adding that up, we're at a cabinet level, but you start looking at facilities, right? We're talking about facilities moving from a 1 megawatt, which used to be considered big, and 5. Folks are bringing on 100 megawatts, 300 megawatts to help support this. Again, I believe a lot of that's for the training portion of it, but it is coming fast. And then from that, as I said, air cooling, I would tell you kind of a general comment. We think air cooling is viable probably for the next 5 to 7 years, right? Depending on your environment. But as you start deploying some level of AI, introducing liquid cooling into your data center in some way, shape, or form, and I'll show a couple different versions of that coming soon, is definitely going to happen. And then the last piece on location, right? So when you built your enterprise on-prem data center, you brought in a couple of redundant lines. you had enough power to run the facility. Hyperscalers were looking for access to large cities, metros, maybe even cheap power. What we're seeing in AI, again, these are larger deployments, is I need to get the power easy. And if the power, which might not be available, right? Some of the grids might not be able to support that. So we're seeing people, bring your own power. So there's folks looking at, alternate energy to support just their facility. And some of that actually includes small SNR, small nuclear reactors. Yep, nuclear, right? Something that hasn't really been talked much about data centers in the past. But some companies are looking at ways to build their own power infrastructure, not finding just the big core and shell that's in a good tax zone and has good fibering, but do they have the ability to bring on their own dedicated power supply because the grid can't support it, and they want to build that wherever it makes sense. So it kind of frees them from proximity choices in the past to, can I generate and create my own power as required? So just a quick look. So this is just an example of what an Nvidia large cabinet pod looks like. I'm just showing this for an example. This actually can be air cooled because they're only putting two of the chassis in there, two 10RU chassis, and the network switches are in the middle. This nets out to about 30 kW per rack, but this is something that can be done in more of a traditional common space or environment. But you can see at the bottom, the fiber counts are tremendous, right? It's that MPO connector I talked about before, and this nets out to 55 plus 100 or 5,500 total fibers to support this. So again, the things that we've heard in the past, you need space, you need power, you need cooling, you need connectivity. This is certainly an example of where you can see where NVIDIA has a large pod deployment. But I had mentioned before, right, the 120 kW. So what does that look like? And this is what you're seeing here. This is fully packed. This is high density. This is the 120 kW Blackwell GPUs that you see being deployed. And this comes out as a complete system, right? As you would expect. It's highly engineered, it's fine-tuned. And you can see there at the bottom, it talks about having, cooling, liquid cooling already coming included, right? So an analogy that just like your car, you wouldn't drive your car without your water pump and your radiator, and that's what these things are. They're a fine-tuned machine, and so it's no surprise that they're coming out fully integrated with all the active gear, the connectivity, the power, and the cooling included. So that's a segue quickly just into cooling in general. As I said, nobody really wanted to bring cooling into the data center, or I'm sorry, liquid into the data center. But two things I want to point here on the chart, right? This is looking at the different colors represent in-row and rack, which is air cooled. Then there's a rear door heat exchanger. And then the yellow slice of pie is direct to the chip. And then green is immersion. For those not familiar, immersion cooling is basically taking all of your active servers and submerging them in a dielectric fluid for better cooling properties. But what I want to point out on these two charts quickly is the shift or change. If you look at the slice on the left, the yellow slice, that's direct to the chip. That says it's about 29% of the market recently. And in the next 8 to 9 years, that slice grows to 57%. Well, if that slice grows, that means another piece of the pie is going to shrink. And that's the blue that you see there, which is in-row and rack, which is air cooling. So that's going to go from estimated from 58% of the market today down to 25%. But I've always told people that air cooling is going to be around for a long, long time, right? Just like people thought on-prem data centers were not going to be around. They're all going to be around for a long, long time. This is just showing the expected shift of liquid to air, and which liquid cooling, in this case, it's direct to the chip, is expected to grab the lion's share as we get into the year 2032. This just shows a little bit about the adoption, right? Kind of the previous slide, but who's deploying what, where, when, and how. So on the x-axis, you can see, as I said, air cooling is viable for the near, mid to long-term future we can see. But you can see quickly when you start getting into, 25, 30 kW, you're getting to air-assisted liquid cooling, active rear door heat exchangers. You start moving to 50 kW and up. You're looking at direct to the chip. And then when you get to the supercomputing, the clusters, you get into the hyperscalers, right? They're looking at immersion cooling going from 150 kW up to 300 kW. So this is sort of a evolution of what the technologies are based across what the requirements are, and then by what segment the expected adoption rates would occur. And just visually to show for those again not familiar, right, what that looks like. So universal Allen containment is a complementary system to help with air-cooled systems like you see in the middle with in-row coolers. And then what you see on the right is that rear door heat exchanger. For, lack of a better term, it's like a big refrigerator door that bolts on the back of the cabinet. It's got a set of cooling elements inside there to help transfer the heat out of that. It's a closed contained system, but there is air in there. You can also do some assist with, there's liquid in there. You can also assist with air, but that's basically what it does, is it's coming on the back of that server cabinet and helping dissipate some of that heat as you go forward. Okay, so what are the considerations for the infrastructure, right? The layer one infrastructure, right? So understanding where you are and how you're gonna get there. Some of the things, right, top of mind, looking at your cable plant and connectivity, things are gonna be different. Looking at cabinet dimensions, I'll get into this a little bit further. Looking at floor loading rates, if you think about that slide I just showed you, right? So some of these systems, these large systems are very heavy, thousands of pounds, and now you bolt on a rear door, you really have to consider, you know, what that cabinet can hold and what your floor loading rate requirements are. Different types of pathways, right? Overhead pathways, people putting multiple levels. You certainly have to consider your in-rack power requirements, the number of outlets, you know, the amperage is increasing, operating temperatures, and it's just covered, right? Do you know what cooling type you're going to want to have, right? Air is viable, right? But then there's the rear door, and then there's directed chip. So how do I provision for that? What am I thinking to enable that as we go forward? And so quickly, just you know, a handful of products. When we think about the fiber piece and connectivity, you know, as I mentioned, fiber is the way to go. Single mode, multi-mode, in this case, Panduit Signature Core, right? When you think about 400 gig and 800 gig, whether it's short reach or long reach, this is super viable. It's great with both protocols. As I mentioned, InfiniBand is the protocol of choice here. But then when you start getting things like our base 8, base 16 connectivity, right? This can help future-proof, you know, avoids the different modules, and you can get better transceiver and server connectivity seamlessly. There's also breakout architectures that allow end users to actually be a little bit more flexible with their deployment, so it actually reduces complexity, reduces the number of switch. There's actually a power savings involved with that, which we have some white papers available on that. But base 8, it certainly is the selection of choice today with an eye on base 16 as we go forward. So things to think about, right? A cassette-based system, looking at multi-node fiber, looking at base 8 as you go forward. As far as the PDUs go, obviously, you know, things don't go in a data center without power and data. So what we're showing here is the universal PDU. What's interesting about that is you can basically standardize on this. If you're a global customer on the call, or if you've got multiple sites, you can standardize on one PDU for all locations. You can reduce the number of cord sets to plug into that. And what's being shown there is a set of combination outlets. Again, not sure what's going to be thrown your way. So we can accommodate all different types of plug types, C13, 15, 19, 21. In this case, it's 36 outlets. And we're seeing definitely a demand for 415 volt and 60 amp. I can tell you there's also an appetite to go beyond 60 amp, getting into the 100 amp range to support these AI deployments. At the core of that, to hold it all together, right, our Flex Fusion cabinets. So again, there's a lot of weight, as I mentioned. So you're looking for something that's strong, robust. I know maybe in the past, folks were using 2-post, 4-post racks. I mean, you really want something that can house a lot of weight and be dynamic. You want things that open airflow, you know, whether it's air cooled or you're going to supplement that with liquid cooling, but you want to make sure you're maximizing that. You're looking at things, I can tell you, you know, obviously we have a full offering in width and depth. You know, I think probably considering a 700, 800 millimeter wide to accommodate for some of the extra space required in the back for access to cabling, power cables, cooling, PDUs, and now, you know, whatever type of cooling you might bolt onto that, you might even be looking for some deeper cabinets beyond the 1200 millimeter. And that's the consideration here, is to start thinking about not just the cabinet, but what might I be bolting onto this cabinet? What might I need to get to the back and get access to? And what would my cooling solution potentially look like? And we talked about, right, so the fiber, again, that there's a lot going inside the data center. So again, we're looking for ways to protect that cable, make it quick, make it flexible, make it modular. So whether it's FiberRunner or wire grid, we have a lot of adaptability and a lot of configurations to be agile. What I'm showing in the lower right is an optical distribution frame, just to highlight that the amount of fibers coming in are going to be distributed out through your facility. So that's a pretty high density deployment you see in the lower right, but ultimately that fiber makes it throughout your environment. So looking at FiberRunner in a combination of wire basket or multiple tiers, as I mentioned before, is something to certainly consider what your fiber counts and your connectivity is going to look like going forward. And then I'd be remiss if I didn't mention, we talked about power, you know, we talked about the gray space. So there's a full offering of Panduit products that we bring forward to help support that as we go forward. So things that for safety and better performance, you know, absence of voltage tester, cable cleats for peace of mind, grounding and bonding, lockout, tagout safety, all is viable. And so ultimately what happens is when you look at that, the benefits are your ability to improve and onboard AI applications, right? So you can reduce things for, deployment time by accounting for those larger cables, higher cable counts, higher pathways densities. I didn't touch much on cable management, but the amount of cable management identification that goes into these systems is huge. Again, think about that cabinet selection. A lot of things start off with the cabinet, looking at things that are taller, deeper, and wider, considering what type of cooling you might be putting on there. And again, looking at your PDUs from a temperature rating and outlet configurations and the power requirements that are necessary. Just to close up again, for us, we feel we have a full solution to help you with. The products are innovative. We've got a lot of expertise and support for you. Got a full partner program to help enable that, certified installers, the work's done in a quality way, the products are done in a quality way. And there's a lot of information we have available on AI if you're looking to gather more of that today. I realize I ran a little long, but for more information, we have a website here. And Kelly, I'm not sure if I left any time for questions or any questions came in, but that's really the end of the content for me.